Hi viewers, welcome to my class on mechanics of materials. In this class, I will be once again discussing another problem on step bar. In the figure, a step bar is shown. Question is to find out the stresses induced in the various sections and total change in length. The Young's modulus of the material is given as 200 gigapascal. So you have three sections here. Each section have uniform cross section. Diameter is given. Okay, diameter is not changing from one end to the other end of that section. And here again the diameter is 60 mm. So from the left end to the right end of that section, diameter is 60 mm. So in each section they are having uniform cross section. So even the third section have uniform cross section, and the cross section is circular and it is having a diameter 80 mm. Loads are acting at the junctions, so you need to find out the force in each section. The lengths are given 0.3 meter, 0.4 meter and 0.6 meter. So first we need to calculate the forces, internal forces in each section. So to reveal the internal forces, you need to consider a section plane and find out the internal force. So to find out the internal force acting in a section, you need to pass a section plane. Which section you want to find out the internal force, which part you want to find out the internal force, there you pass a section plane and consider the equilibrium of one side of the bar. One side, if you consider equilibrium of one side, if you consider, you can find out the internal force in that particular part. So let us take the section plane here and then find out the internal force in this first section, and I'll put the internal force as P1. Okay. And next we will pass the section plane here and again another section plane here. I'll explain it in the next figure. So passing a section plane 1 1, now we need to consider the equilibrium of this portion. Okay, I am removing the left part, I am considering the equilibrium of this right portion. So you have forces 50 kilonewton, 140 kilonewton and this 70 kilonewton. As I told in the previous class, easiest way is when you consider the right portion. The left portion it's not applicable. When you consider the right portion, you can treat the rightward forces as positive and leftward forces as negative. So to find out the internal force induced in this section, you take only this portion, okay, and consider all forces acting on that particular portion and sum up the forces by taking rightward as positive. So this is rightward, so 50, and this rightward, so plus 140, and this is leftward minus 70, which will give 150 plus 140, 190 minus 70, 120 kilonewton. So that is the internal force which is coming. You can also do the same thing by summing up the forces on left part. Removing this, if you consider only this part, it is 120 kilonewton, but in that case you should take leftward as positive. If you are considering the left portion, you should take leftward as positive. So that will be confusing when you consider the sign convention. So it's better to take the right portion and sum up the forces by taking rightward as positive and leftward as negative. So you are getting a positive value for the force. Positive value means the force is, net force is acting rightward and this is leftward. So on this portion you will have tensile force. So when you consider the forces on the right part beyond the section plane, if you are getting a positive value, that means the internal force acting is tensile. So this part is under tension or that part is elongating. Now coming to the second, find out the internal force in the second section. Pass a section plane and then take the right side portion beyond the section plane, somewhere in the, it can be anywhere in that section, because this force is acting here at the junction. So pass the section plane anywhere in between and then consider the right portion. So you have 140 plus 140 because it's rightward, minus 70 because it's leftward. So you get 70 kilonewton plus 70 once again, and that internal force in this part is tensile. So this is tensile, it's also tensile. So this part is will elongate because tensile force is acting in that part, it will elongate. Now let us take this portion, and I am passing the section plane there, considering only right side. You are taking the forces beyond that section 3. So you are passing the section plane considering the forces on right side. So you get minus 70 because it's towards left, the force is towards left, minus 70 or minus 70 kilonewton. Now if you are considering the left portion also, you can get the same result, but you need to take this leftward as positive. So plus 120, this will be minus 50, and this will be like minus 140. So that sign convention will be confusing. So take the right portion and sum up. So wherever you pass the section plane to reveal the internal force, you consider the right part, sum up with the rightward force as positive, so and leftward as negative. So that way you can find out the internal forces. So you got internal force in the all the three sections. Now, so I have written that values. So you have 120 kilonewton means 120 into 10 raised to 3. It is Newton. Okay, I have not written the unit here. 120 into, I have converted into Newton. So 70 into 10 raised to 3 Newton minus 70 into 10 raised to 3 Newton. Now you can find out the stress in each section. So it's P1 is 120 into 10 raised to 3 Newton divided by area is pi by 4 into diameter square, because it's circular cross section. You need to find out the area as pi by 4 d square or pi r square. Pi r square means pi into radius will be 20, pi into 20 square you can use. So you are getting the stress in that particular section. First section has 95.493 Newton per mm square. So it is subjected to a stress of so much, and every mm square of that cross section is resisting a load of 95.493 Newton. Coming to the second section, the load is known, 70 into 10 raised to 3 Newton, and area of cross section, since the diameter is 60 mm, area of cross section is pi by 4 into 60 square. So it's equal to 24.757 Newton per mm square. The stress in the third section is P3 by A3, and P3 is compressive force, so minus sign you can retain. So minus 70 into 10 raised to 3, the diameter is 80, so you can calculate the area. So load divided by area of cross section, which gives the stress as minus 13.926 Newton per mm square. Minus shows that it is a compressive stress. Now the change in length of each section is formula is P1L1 divided by A1E1. Alternately, you can replace P1 by A1 as sigma 1. So you can also write sigma 1 into L1 by E1. Since sigma 1 you have already calculated, that is stress in the first section you have already calculated, you can also use sigma 1 L1 divided by E1. Okay, let us use P1 L1 divided by A1 E1. So the load, the length, area of cross section of first section, the Young's modulus is 200 gigapascal. 200 gigapascal is 200 into 10 raised to 3 Newton per mm square. So it is 2 into 10 raised to 5. So that works out to 0.1432 mm. Similarly, you can find out the change in length of second section, and the load in that section is 70 kilonewton. So 70 into 10 raised to 3 Newton. The length of that section is 400 mm. See, the length of that section is 400 mm because it's 0.4 meter. 0.3 meter means 300 mm, 0.4 400 mm, and 0.6 is 600 mm. So 400 mm, and the area of cross section is substituted, and the Young's modulus is 2 into 10 raised to 5, which works out to 0.0495 mm. And the elongation, and this is not elongation, the change in length of third section, you substitute that negative value here for the force. Internal force is minus 70 into 10 raised to 3. That means its force is compressive, and finally there will be a reduction in length. So length is 600 mm, area is substituted, Young's modulus is substituted, you are getting minus 0.0418 mm. This minus sign indicates a reduction in length. You can always keep that minus sign for the nature of force, and finally you will be getting minus indicating a reduction in length. So the advantage of using this minus sign is you are getting the reduction of length here. The advantage of using minus sign is you can directly add now. You need not identify which section is undergoing reduction, which section is elongating. You can directly add all the values which you are getting, and then you can find out the total change in length. So you add that delta L1, delta L2, delta L3, which will give the total change in length. So after adding, keeping that negative sign, after adding you will get the total change in length as 0.151 mm. So here after adding I am getting a plus sign. Plus sign means there is an elongation, for the entire length is getting increased. The bar is total length of the bar is increasing by 0.15 mm. By chance if you get a negative sign, that means there is a reduction in length in the total length of the bar. Okay, individual sections may elongate or decrease in length. So but finally there will be an elongation. Third section is decreasing in length, so much decrease is there, 0.0418 mm decrease is there. But since first and second section are elongating, the net change is elongation 0.15 mm. So this is the total change in length. There is a increasing length of 0.151 mm. So that's all for today. Thank you for watching.